Good day, everyone. Let me present to you some examples of the probability of an event. From problem number 1, when a dice is rolled, find the probability of an odd number is obtained. Now we are going to use the formula of the classical probability. Then if we're going to identify, dice has 6 choices, which are numbers 1 to 6. Then numbers are the sample space of the experiment denoted as S. Now the event for an odd number is 3 choices denoted as E. So let us go back to the formula. Then we can now directly substitute the values to the formula. And the result is equal to 1 all over 2. So the probability of odd numbers to the rolled dice is only 50% from its original choices. Let us proceed to the next example. 2 dice are rolled. Then find the probability that the sum is equal to 2. Every dice has 6 choices. Now because with those 2 dice, then the sample space will be multiplied by its 6 choices. The first choice of 1 dice will be partnered with one of the choices of other dice. Now we are going to find the probability that the sum is equal to 2. This is the only probability among the probabilities that the sum is equal to 2. This is the only sample space among the sample space from experiment that the sum is equal to 2. Then we can now use the formula of the classical probability. Then substitute the values to the formula. The number of even is only 1, while the number of samples is 36. So the answer is 1 all over 36, or approximately only 2.7% of 36 sample space. Then how about the probability that the sum is equal to 10? Now we will do the same procedure as equal to 2, but here we're looking for the sum of 10 among sample space. Then the result is only 3 events from 36 sample spaces. And we can now directly substitute the formula, and the result is equal to 1 all over 12, or approximately 8.3%. Now how about if it is less than 9? From the given sample space, the probabilities that have a sum of less than 9 got 26 events. Then if we're going to substitute to the formula, we can find the probability of an event that is equal to 13 all over 18, or approximately 72%. Let us try to check this one. Problem number 3. A dice was rolled and a coin was tossed. Now the question is, find the probability that the dice shows an odd number and the coin shows a tail. A dice has 6 choices, 1 to 6, while the coin has 2 choices, the head and tail, as shown this way. So we're looking for an odd number together with a tail as stated in the problem. So the number of events is only 3 among the sample space. Then we can now directly substitute to the formula. The answer is equal to 1/4 or 25% of the sample space of the experiment. Now how about this kind of problem? Problem number 5. A card is drawn at random from a deck of cards. Now find the probability of getting a king. As we can see, we have 52 cards shown in the figure. Then the number of getting a king card is 4 as the number of events. Now if we substitute the values to the formula, the answer is equal to 1 all over 13 or approximately 7.7% as the probability of getting a king card. Let us proceed to the next example. A jar contains 5 red marbles, 7 green marbles, and 11 white marbles. If a marble is drawn from the jar at random, what is the probability that this marble is green? As we can see in the problem, a jar contains a total of 23 marbles. But the number of the event under green marbles are only 7 from 23 marbles. Therefore, if we substitute it to the formula that we will going to use as frequency, then the result is equal to 7 all over 23 or approximately 30.4% of 23 marbles. For the next problem, the blood groups of 120 people are distributed as follows. 45 have type A blood, 35 have a B blood type, 15 have the O blood type, and the rest have type AB blood. If a person from this group is selected at random, what is the probability that this person has an AB blood type? The first thing that we need to do is to find out how many total people belong to type AB blood. The answer is equal to 25. Now let us substitute all of the given values to their corresponding formula of frequency. So the answer is equal to 5 all over 24 or approximately 20.83% belongs to the type AB blood. For example number 8, find the probability of getting a numbered card when a card is drawn from the pack of 52 cards. In this example, we're looking for numbered cards among 52 cards. The formula that we were going to use is classical probability. The number of events ranges from numbers 2 to 10 is 9, then multiplied by 4 as 4 suits in every numbered card. Therefore, that is equal to 36 events. So if we are going to substitute the values to the formula, the answer is equal to 9 all over 13 or approximately 69% of 52 cards. For problem number 9, find the probability of getting an even numbered card when a card is drawn from the pack of 52 cards. In this problem, we're going to use the same procedure from the previous as we're looking at the probability. But we will just focus on the even numbered card as stated in the problem. So we found out that the even number cards consist of 5 with numbered cards of 2, 4, 6, 8, and 10. So we will multiply it by its suit, which is equal to 4. Then the total number of events is equal to 20 events. So if we're going to substitute the given values to the formula, the result is equal to 5 all over 13, or approximately 38% of 52 cards. For the last problem, one card is drawn at random from the pack of 52 cards. Now the question is, find the probability that it is an honored card, and in the next one, if it is a faced card. We're looking for the two requirements here when it comes to the last problem. So we will use the formula of classical probability. We will first solve for the honor card. The number of honor cards is only 4, but we need to multiply it by 4 as the suit of every card. Therefore, the total events are equal to 16. Then we substitute it to the formula. Therefore, the answer is equal to 4 all over 13, or that is approximately 30% of total cards. So for the second requirement, we will use the same procedure as the first requirement. The total events of the face card are equal to 12. Then we substitute it to the formula. Therefore, the answer is equal to 3 all over 13, or that is approximately 24% of total cards. All examples were used by the formula for classical probability and frequency. That's all for now, and keep safe everyone.